Hello everyone, welcome back. In this video we are going to discuss about the schemas, that is star schema and snowflake schema, and then we are going to discuss about the dimensions and measures. As I said, the data will be flowing from OLTP to OLAP, that is a relational OLAP, and then from relational OLAP you will be loading into the OLAP, that is multidimensional OLAP. Here in the roll app, the tables are created in the form of schemas. Okay, so we have two types of schemas, that is a star and next is snowflakes. Then in the OLAP we have the dimensions and measures. Okay, snowflakes. So this here, what is meant by star schema and snowflake schema I am going to explain, and what is the dimension and measure, that one we are going to explain. So here the star schema is nothing but, generally you see you have a table, and if you want to get any information for the table you have to join with the other table. Okay, so in the star schema you will have the table fact at the center, you will have the dimension table at the in the next level. Dimension tables are surrounding, nothing but I have given the diagram as a surrounding. But in the fact table, if you want to get any information, you will just join, only one level of joining is required. The best example for this is, let's take, I have a table where I have the table for the product key, fact table. I have the product table, fact table as product key and the quantity. I got it. So product key is P1 and the quantity is 20. If I want to get any information regarding the product, there will be a table called product. This is nothing but the sales. Let's assume this is a fact sales, facts F sales. This is a dimension, a dim product. This is a dimension product. So I'll have the product key, product to key. Then I'll have the product information like product description. Then I'll have the alternate key, something like that. So many columns will be there. If I want to get any information regarding the product, I'll join with the product key and I'll get the information with the product. That is only one level of joining. So nothing but, if I want to get the same information regarding to some customer, same fact sales will have the customer key. I'm writing a shortcut as customer key. Then that customer information will be stored in a separate table called dim customer. So in order to get the customer information, from the fact table you will joining the dim customer on a dim customer key. I am writing only C key. This is the customer key. You will have the name for the customer and so blah blah blah. That is nothing but, for every fact table, if you want to get any for the fact table, if you want to get any relation information, you will join only, you will do only one level of joining. Nothing but, you will have the fact table at the center and you will have the dimensions surrounded by it. So if you want to get any information, you will join it one time. That's only one level of joining is required for all the information that you need. That is nothing but the star schema. Next is snowflake schema. In the snowflake schema, you will have the fact table at the center, you will have the dimension table, same like the fact table only. You will have the dimension, let's say same like the star schema. In the star schema, you will have fact table at the center, then you will have the dimension table surrounding, and for any information you need, you will do only one level of joining. That is a star schema. In the snowflake schema, you will have the fact table, same like the star schema only, you will have it. But if you want to get the information, you might be doing two levels of joining. You will have the dimension, you are good, dimension, you are good. You will have the two levels of joining for the snowflake schema. Okay, the best example for this is, we'll have the same fact sales, we'll have the same fact dim product, but dim product might have a one more column called it might have the category key. Okay, category key, and again you will have one more table called dim category. that will have the information for the category. Category means which category it is related to. The way you might have some product with the biscuit. Biscuits are related to snacks. Some candies, they are all related to some snacks. You might have products like some cold some tablets or some medicines, that all goes under the healthcare, like that. Okay, so that category information will be stored in the dim category table. Now if you want to get the category, first you have to join with the dim product, and from dim product again you have to join by using the category to the category table to get the category information. This will have the category, it will have the category description or some information regarding to the category. So here you will be doing two levels of joining for the same, for some information. This two levels of joining is nothing but the snowflake schema. You will have the fact table at the center, then you will have the dimension table, and then the dimension table again as a one more level of dimension table. This is a snowflake schema. So now what is a star schema and snowflake schema is? Star schema, you will have the fact table, you will have the dimension table surrounding to the fact table. This is the star schema. Next, snowflakes schema. Next, snowflake schema, it is the same like the star schema. It you will have the fact table, then you will have the dimension table, and this dimension table will again have one more level. This is nothing but the snowflake schema. So if you want to get any information, you might need to join two tables, like two levels of joining is required. First you have to join with this table, again this dim table again will join with the other dim table. That is nothing but the snowflake schema. Fact schema, this star schema is you will directly join with the dim table directly. Okay, this is a star schema and snowflake schema. Now we are going to see about the, this is in the role app. We have the schema star and snowflakes. We are good. Now OLAP, that is the multi-dimension. In a multi-dimension you will always deal with the dimensions and measures. Okay, so based on these facts and dimension tables, this is based on the stars and snowflake schema. So in the OLAP you will always have the facts and dimension tables. The tables are facts and dimension tables. Okay, that one at the end of this end of this course I am going to give you one project, then you will be clear with this complete OLAP, OLTP and OLAP. We will have some tables on the OLTP, then based on these tables you are going to convert the tables into the OLAP, like denormalize the tables, then on the tables you are going to build a cube. That all we are going to see there. Okay, end of this course we will have a project, so you will be getting that is a practical thing, then you will be understanding it clearly. You will be getting a complete picture on that what we are doing now. Now the same after this OLAP rollup, relational OLAP, we will take the data as a source and we will build the multi-dimensional online analytical processing. This is MOLAP. Okay, so for the MOLAP you might get it from OLTP or you might get it from the OLAP, relational OLAP. That's fine. Okay, generally we will be taking from relational OLAP. And in the MOLAP we basically we deal with the dimensions and measures. What is a dimension, what is a measure? Measures are nothing but it's a value on which a mathematical function can be performed, like quantity and amount. Whenever you build the facts and dimension tables like star schema, snowflake schema, you will always have the quantity as a quantity, sales amount, sales quantity, then you might have the return to quantity. That all the quantity and amounts are nothing but the measures where you can perform the mathematical function like sum, minimum, max, total, average, mean, median, mode. That all you can perform on that. That is nothing but the measure. Dimension is nothing but which provides content text to the measures. Okay, context to the measure. Okay, let's take Apple. Apple has announced quarterly results. It announced some results. It says Quantity, I have the sales as 300. What is meant by sales 300? 300 millions. It doesn't make any sense. But if they add for quarter 1 2016, if I made the sales of 300 millions, that is nothing but you are adding context to the measures. This is nothing but the dimensions. Okay, and to the same 300, out of 300 million I can say, okay, I have sold iPhone 6. iPhone 6, the quantity I have sold 300 millions of iPhone 6. Nothing but this is a product. This is nothing but you are giving context to the 300 million. This is nothing but the dimension. So date, location, that all comes under the dimensions. Measure and dimension. Measure is nothing but it is a value, it is a quantity, amount, that all where you can perform the mathematical function. Then mathematical function, average, sum, minimum, max, medium, that all. Dimension is nothing but which provide context to the measures, nothing but the product date. This is a measure and dimension. So in this class we have seen the schemas, star schema and snowflake schema. Then we have also seen the measures and dimensions. That is nothing but the MOLAPs related stuff, and we also seen the rollup related stuff. This is a basic, but we have many things in the star schema. That is the bottom up approach, top down approach. That this class will not be sufficient for that. So if you search more lines regarding the star schema and snowflake schema, Google, then you'll get more information. You'll get some books for this. The same with the dimensions image. If you want to learn more, then you can get to the, you can go to the Google and search, then you'll get more info. From the database perspective, this is the dimensions. Okay, you'll also have that's in different Tableau reporting perspective. But general scenario is this is a dimension, means it is a context to the measures, which provide context to the measures. Measures means always a quantity and amount that are called as the measures. So thank you guys. See you. We'll meet in the next video.